Hello everyone, thank you for stopping by. My name is Bino. In this Math Olympiad question, we are given four circles which are tangent to each other consecutively and to the lines AB and AC, and we are told that AD is collinear to the centers of the circle. We are given that the radius of the first circle is 5 centimeters and that of the fourth circle is equal to 40 centimeters. We have to determine the radius of the second circle. We are going to determine the radius of the second circle manually without the use of the geometric formula. We are going to name the center of the first circle as center M and that of the second circle as center N, and we name the center of the third circle as O and that of the larger circle as P. We introduce a radius from the center P to the point of tangency, where we know that the angle will be equal to 90 degrees, and from the center O to the point of tangency we also have 90 degrees, introducing another radius from the center N to the point of tangency, and finally from the center M to the point of tangency. This question will be solved by introducing three lines from the center M, N and O, and these lines must be parallel to the line AB. We have a line from the center M to the radius of the second circle, and it's parallel to AB at the point E. And we also introduce another line from the center N, which will be parallel to AB at that point, which we call point F. We introduce another line from the center O to the radius of the last circle, which will be parallel to AB at that point G. We were given the radius of the first circle as equals to 5, but we are not given the radius of the second circle, so we call the radius of the second circle Q, and the radius of the third circle we denote it with the letter R, and we are given the radius of the last circle as equals to 40 centimeters. We isolate the first and the second circle, so the first circle we had radius 5 and the second circle radius Q. The radius of the first circle was equal to 5, and since this is a rectangle, that side will also be equal to 5, and we'll be left with that length EN. So the length EN will be equal to, so we know that total length is the radius, so EN will be equal to the bigger radius Q minus 5. So our EN will be equal to the radius of the second circle Q minus the radius of the first circle. And the FO, for our FO, we have that radius of the second circle, which will be equal to that part because we have a rectangle. So our FO will be equal to R minus Q, and in the same way the GP will be equals to the 40 minus the R. Suppose we have three lines which are parallel to each other, and we have a line cutting through the three lines. So if that angle there is beta, that angle will also be equal to beta. Same applies to that angle. In our case, we have the radius which are tangent to AB parallel to each other. And since the line AD is common, if that angle is equal to theta, then that angle will also be equal to theta, including the angle in MEN. So a triangle MEN will be similar to triangle NFO, which is similar again to a triangle OGP. And given that we have triangles which are similar, so we know that MN divided by EN will be equal to NO divided by FO, which will also be equal to OP divided by GP. We will use this similarity theorem later on to create two equations. For now, we determine the center to center distance. So we have mn, which will be equal to the radius 5 plus the radius q, and the center to center no will be equals to the radius q plus the radius r, and op will be equals to r plus 40. And this is because AD is collinear to the centers, so the OP will be equals to the radius r and the radius of the larger circle, which is equals to 40. And from here, we create two equations from this similarity theorem. Our mn divided by en will be equals to no divided by fo, and no divided by fo will be equals to op divided by the gp. So we determine that mn is equal to 5 plus q, and that en is equals to q minus 5, and this is equals to no, which we determined as q plus r, divided by fo, which we determined as r minus q. So on this side we have no, the q plus r, divided by fo, the r minus q, equal op, which is equals to r plus 40, divided by gp, which is equals to 40 minus r. Let's focus on this equation for now. We cross multiply and we have 5 plus q, which will be multiplied by the r minus q, and this will be equals to the q plus r multiplied with the q minus 5. Distributing the 5, we have 5r minus 5q. We distribute the q, and we have q multiplied by r minus q squared, which is equals to the q squared after distributing the q minus 5q, and we distribute the r, and we get the qr minus 5 multiplied by the r. And from here, the qr and the qr will cancel, and the negative 5q and the negative 5q cancel, and the q squared minus this q squared will be equals to negative 2q squared, and this will be equals to, so this 5r, we move it to the right and it will minus with that 5r, and we get negative 10r. Dividing both sides of the equation by negative 2, we get q squared is equals to 5r. So let's move on to this equation. So we paste that equation and we immediately cross multiply. So we have q plus r multiplied by the 40 minus r, and this is equal the r plus 40 multiplied by the r minus q. On the left hand side, we distribute the q, so we have 40q minus q multiplied by r, and we distribute the r, and we have 40r minus r squared, and this will be equals to the r multiplied by r, which is r squared, minus qr. Distributing the 40, we have 40r, and we have a negative 40 multiplied by q, and the negative qr and that negative qr will cancel out, and the 40r and that 40r will cancel out. So the 40q, taking it to the left, it will plus with that 40q, and we'll have 80q, and this will be equals to, so this negative r squared, we take it from the left to the right, it will be positive and plus with that r squared, and we'll have 2r squared. We divide through the equation by 2, and 40q will be equals to r squared. We now consider this equation which we abandoned. We paste the equation and we divide the q squared by 5, and our r will be equals to q squared divided by 5. So from here we have 40q, and in the place of the r we are going to substitute the q squared divided by 5, but the r was squared, so this will also be squared. So 40q will be equals to q to the power 4 divided by 5 squared, the 25, multiplying the 40 by the 25, or we cross multiply, and our 1000q will be equals to q to the power 4, and we divide through the equation by q, and 1000 will be equals to q cubed, and our q will be determined by cube rooting both sides of the equation. So the numerical value of the q, the radius of the second circle, will be equals to the cube root of 1000, which is equals to 10 centimeters. Thank you guys for watching. If you have any questions, you can drop them in the comment section below. Remember to subscribe, like, and share the channel if you find this content useful.